Hello, welcome to this lesson on precipitation reactions. The question of the day, what does precipitation mean in earth science? What is a precipitate, the noun? And what does precipitation mean in chemistry? A precipitate is a solid that comes out of solution from a chemical reaction or from a drop in temperature. We spoke about the precipitate resulting from a drop in temperature in the saturation curves lesson, so if you missed that, be sure to go back and watch that. Today we're going to be talking about precipitates as they form from chemical reactions. The precipitation reaction is a type of double replacement reaction where, if you don't remember, your positive and negative ions are going to swap partners. So let's say we have two ionic compounds. We have compound A, B. A is going to be positive, and I know this because it's written first. B is going to be the negative ion, written second. Positives always come before negatives in our chemical formulas. It is going to have a reaction with CD where they go and swap partners. So A will pair up with D because D is the other negative ion. B, being negative, will pair up with C, the other positive ion. That's going to give us AD and CB. Again, it's CB, not alphabetical, because C is positive and B is negative. So specifically in a precipitation reaction, one of the products in that double replacement will be a precipitate. So in this example, we have AB in the dropper and we have CD, the two reactants. This is going to be the solution that was in the test tube. And once those two things are mixed, one of them is going to stay as its ions. It's going to be dissolved somewhere in this test tube. But the second thing, the solid that forms the precipitate, will be either the new compound AD or the new compound CB. A precipitation can only occur if both reactants are soluble, because it's the only way to get the ions to break apart so that they're able to swap partners. Of the two products, only one of them should be soluble. If they're both soluble, then that really just means that all of your ions are just kind of like floating around. But if we have just one of them being soluble, that means that the second insoluble product would be the precipitate. So here is a real life example. We have sodium chloride. Na is a group 1 ion, so it is always soluble with no exceptions. And then we have silver nitrate, and nitrates are one of those ions that are always soluble with no exceptions as well. So they're going to swap. Sodium is going to pair up with the nitrate, Ad, and we get sodium nitrate. And Cb will be silver bonded to chlorine. Now, if you don't remember solubility rules, I will have that video linked in the description. But silver chloride is an insoluble product. Halides, chlorine, would really like to dissolve, but silver is going to prevent the chlorine from dissolving. So in this case, both of our reactants are soluble, which we would represent with this AQ for aqueous. The sodium nitrate is also aqueous. It will dissolve in the water, but the silver chloride will not, hence the S representing solid. So to begin, we would have all of our ions kind of swimming around because remember, they're all soluble. So once they hit the water, they will dissociate. But once we have our result here, we will have the silver chloride precipitate sitting on the bottom of the container while the sodium and the nitrate ions continue to swim around in the water. In order to get that solid product out of the water, typically we're going to use a filter or a filtration system. So the filter is going to catch the precipitate where the water and all of the dissolved ions are going to pass through the filter and into your receiving flask or beaker. The most common questions that you will be asked on these precipitation reactions is something like this. You will be given two reactants and asked to predict the products. So the first thing you're going to do is check out your solubility rules to see if both of your reactants are able to dissolve, because that's the only way we're going to get a reaction to happen. So looking at this, nitrates are always soluble with no exceptions. So this is going to be aqueous. We will also have the same situation with the potassium chloride because potassium is a group 1 ion and it's always soluble. So knowing that these two compounds will dissolve, now it is time to swap ions. So when I swap, I am going to have silver match up with chlorine. So I would get silver bonded to chlorine. In this case, they both have 1 for their charge. Silver is +1 and chlorine is -1, so I would get AgCl. And then with the remainder, I would have potassium nitrate. Potassium is a +1 and nitrate is a -1. So when those crisscross, I would get just KNO3. And now I need to determine if my products are soluble or insoluble. So looking here, the potassium and the nitrate, they're both always soluble with no exceptions. So these ions will continue floating around in the water. But silver chloride, just like our example before, is insoluble. So the result will be a solid product sitting on the bottom of the container. My reaction is balanced. I have 1 of every atom here, except for 3 of the oxygens. I usually balance these with the NO3 intact since the poly is not breaking. So I have 1 of every ion. And this is our correct answer. Let's take a look at another one. Next up, we have sodium carbonate, and this is sulfuric acid. This H in front would tell you it's an acid. That's aside from the point. Right now, we want to take a look and see if our reactants here are soluble, because it's the only way that they will be able to swap partners and react. So looking at the sodium carbonate, sodium is a group 1 ion, so it will always dissolve with no exceptions. So that sodium carbonate will be aqueous. The same is true for the sulfuric acid. Hydrogen is a group 1 ion, so it'll always dissolve with no exceptions. Sulfates don't love to dissolve, and neither do the carbonates, but they are bonded to ions that dissolve all the time, so that's not relevant at this point. Because both of our reactants are soluble, they are able to swap partners. So I am going to take my positive ion from here and pair it with the negative ion from over there. And in this case, my sodium has a +1 charge and the sulfate has a -2. You could either memorize that or uncrisscross this 2 right here. So when I cross the sodium and the sulfate, I would get Na2SO4. And then I need the positive and negative that are left over, and that's going to be the hydrogen and the carbonate. Hydrogen has a +1 charge, which this sulfate is wrapped in imaginary parentheses with a little 1 back here, because this 4 belongs to the sulfate ion. So the hydrogen has a +1 charge, and the carbonate over here, you uncrisscross, and it has a -2 charge. That is going to result in the formula H2CO3. So far, my equation is balanced. I have 2 sodiums, 2 hydrogens, 1 carbonate, and 1 sulfate on each side. And now I want to take a look at my products to see if any of them are soluble. So the sodium sulfate, sodium is a group 1 ion, so it's always soluble with no exceptions. And the same is true for that hydrogen. So this is a little weird because everything turned out soluble, which really means that we have no reaction happening. Oftentimes you'll just see that written as no RXN, no reaction. This is because our ions aren't really swapping. They are, everything that could possibly be made here is always soluble with no exceptions. So all of our ions are just going to float around. They have no desire to bond. They are attracted by the water molecules, so truthfully, nothing's going to happen here. Here's the final example. We have chromium 3 sulfate and sodium nitrate trying to have a reaction. So we will look up solubility rules. Sulfates do not like to dissolve, and chromium is not an example of an ion that would force the sulfate to dissolve, meaning that this is a solid. It's not aqueous. Really, at this point, we should know that there's no reaction happening. This is because you're not going to be able to break apart the chromium 3 sulfate just using water. You may be able to break it in some other circumstances, but it really does not want to break apart. So this is going to result in no reaction. And the reason is because one of our reactants is insoluble in water. They can't have a precipitate reaction. Even though the Na is a group 1 ion and sodium nitrate loves to dissolve because the nitrate also is always soluble with no exceptions. This fact that the chromium 3 sulfate is insoluble and is a solid product, or a solid substance rather, prevents the reaction from happening altogether. So that is the 3 ways that you can get a precipitation question. You will have no reaction because you have an insoluble reactant. You could have a no reaction because all of your substances are aqueous, or classic, you have a precipitate, which is going to be your solid product, and some aqueous ions floating around. So that's all for the video. Please subscribe so you don't miss the next lesson. Leave any questions you have in the comments below the video. I'm happy to help you. And that's all. I'll see you in the next one. Bye.